what now?
The other one still has to accept.
Why do you say it's the wrong list of exceptions?
It's still not.
Oh, sorry. Yeah, I understand what you're saying now. So those are compounds that are insoluble. All right. So if I look at the next one, look at copper. Copper is not one that's on our list, but I have to look at what happens with the phosphate ion. So most of the phosphates are insoluble. The exceptions are as if they're in the things that are in the 1A family, the alkali metals. So that's not one of those. So that's an insoluble. Same with the cobalt carbonate, insoluble. So carbonates and phosphates behave the same. However, the last one, the phosphate ion, is now with potassium. Potassium is in the 1A family. It's one of the exceptions to the rule. So being in the 1A family are always soluble. So this one would be soluble. So that's the only one that is soluble in this list. Okay, let's go some more. So I'm just going to choose one of these. You all want to pick one? A through D? B? Okay. So I want to write the complete reaction and then balance it and find out if there's a reaction that occurs. Okay, so on this one, I've got the sodium cation and I've got the mercurous cation and the acetate. So I'm going to first associate it to the ions, so the sodium and the chlorine. And the mercurous cation, this one is it's one of the rare ones, but we've talked about it. And this guy is the acetate ion. So then I'm going to pair them up.
How do you know it's
I don't know, it's this guy.
down there because, I get that you like.
Well, this is one of the ones that's on the previous table. Mercury doesn't form a monomer. So mercury always forms a dimer. We've talked about that in class a couple of times. It's the unique one in the periodic table. It's one of the few elements that does that. But that's the properties of mercury. Okay, so now what we do is we exchange our ions. So the chlorine is going to pair with the mercury. The sodium is going to pair with the acetate in our product. So if I pair them up, I'm going to form the sodium chloride plus the mercury, and I'm going to form the, sodium's with the chloride. Ready? Form sodium acetate. Wrote it. Paired them at the top, but didn't at the bottom. Sodium acetate, and then the mercury is going to go with the chloride. The chlorine's -1, mercury's +2, so it's going to be 2. And then I need to distinguish the phases that are with them. So the sodium acetate, all the sodium salts are going to be soluble. So that's going to be AQ for aqueous. Mercury was one of the ones that, with the halogens, that formed a precipitate, so that's going to have a solid associated with it. So now I look at to balance that. So I've got 2 mercuries on the left, 2 mercuries on the right. I've got 2 chlorines on the right-hand side. I'm going to have a 2 on the left-hand side. On the acetates, I've got 2. Where is that? 2 here. I don't have a 2 there. So to get the 2 acetates, I need a 2 in front of that. So that gives me my 2 sodiums, my 2 acetates, my 2 chlorines. So that would balance it. So that would be the complete equation. Now to do it as a, this one doesn't say a net, so that'll be on the next one. So that would be, it would be a 2 to 1 to 2 to 1 ratio on this one. All right, so, and this would, that should be a forward arrow there. All right, balance that. All All right, so these we're going to go from name to compound. Choose one. C. All right. Cesium chloride. Cesium in the periodic table is in the 1A family. So that means it's a 1 charge, plus 1 charge. So it's going to be the cesium and the chloride. Are going to be the ions from it. The calcium sulfide. Calcium's plus 2 from the 2A family. The sulfide is a -2. So now I'm going to pair up the opposites. So the chlorine and the calcium is going to pair. The cesium and the sulfide are going to pair. So cesium and the sulfide. Sulfide's -2, cesium's +1, so there's going to have to be a 2. Okay. If I go back to look at the calcium and the chloride, calcium's +2, chloride's -1, it's going to be a 2. Calcium chloride is a water-soluble compound. Most of the sulfides, there you go, go back to your table, there it is. Most of the sulfide compounds are typically insoluble. The ones that are slightly soluble is that if it's paired with calcium. So in this case, it is a soluble compound. So it forms soluble calcium sulfide. It's an AQ. You get to mark that. All right. It wants to know, is there precipitation that occurs? In this case, there's not. So if those are both soluble, that means that everything's a spectator ion. This would be an example of a no reaction. Sorry.
That's cesium.
Cesium. Sorry.
So it would make.
Let's go back to our. Make sure that's not an exception. It's not an exception in there. So it is going to form a precipitant. Thank you. So it's cesium. It would form a precipitate. So then you're going to have a reaction that occurs. So you're going to form a solid in this one. All right. To balance it, you would have cesium chloride plus calcium sulfide. That's a 2,2. Yields cesium sulfide and calcium chloride. I'm going to have a 2 here. That does it. Okay, it balances the reaction. Yep.
Why is it written CaCO and not COC?
You always name metal first. Okay, so always put the metal first, or in the formula as well as in naming, and then follow it with the non-metal or the polyatomic ion. But metal always goes first in the formulas. Other questions? Okay. You want to do more of these, or you want to go to electrochemistry? Okay, so this one, we want to go to the net, and we haven't done one with a net. So we want to do a balanced ionic equation and then go to a net. Pick one. Okay. So first thing I want to do is break it into the ions. And then I've got to repair them. On this one, it's actually already repairing them for me. But the only thing I have to do is determine what's going to happen with these species. It's telling me that it's going to make a solid, so it's giving me that information. Key thing I realize is that this being aqueous, that they're staying in solution. Okay, so that is going to be my my complete ionic equation. I need to balance it to make it work. So if I balance this guy, I'll just balance it up here on these. All right, there's 2 iodides on the left, so make it 2 here. We've got 2 potassiums, 1 calcium, 1 calcium, 1 sulfate, 1 sulfate, so that 2 balances the equation. All right, so that's balanced. Now to get the net equation, what I do is cancel out the things that that stay in solution. So the iodide and the potassium stay in solution on this. So the net equation is simply the calcium plus the sulfate. And on mastering chemistry, you have to show the phases. That's one of the tricks to it. Produces the calcium sulfate solid.
Do you keep the charges there?
Yes. So at this phase, it's the ions that are reacting. Okay. Another question? All right. This is the same type of question. You're just writing it out, so you've got to go from name to formula. So it says that lead ions, it tells me lead 2 plus, can be removed from a solution by precipitation with the sulfate or with the sulfate ions, SO42 minus. Key is to be able to go from name to formula to make this work. So if I had a solution that contains lead nitrate, so that means the lead also has nitrate in it from the name, and I wanted to precipitate that out with potassium sulfate. So the potassium has sulfate, or the sulfate has potassium paired to it, and then from the solids, it's forming the lead sulfate, solid, and aqueous potassium nitrate. Once you get to that point, it's just a balancing reaction. So this is the lead nitrate, aqueous, plus potassium sulfate, aqueous, and we have to balance those two. So balancing, I'd have to put a 2 in the potassium. There's already 2 nitrates, 1 lead, 1 sulfate. That's all you have to do to balance it. Okay. Go forwards. All right. Balance net reactions. Let's do something different. So let's get some redox stuff. This is a titration one where you're doing a certain volume and concentration. So I've got 30 ml sample of unknown H3PO4, that's phosphoric acid, reacts with a certain concentration of NaOH. It tells me that it takes 26.38 milliliters of NaOH to neutralize that solution or reach the equivalence point. I want to take that piece of information and find out what is the concentration or the molarity of the phosphoric acid, H3PO4. And the key to realize on this problem is I've got a volume and a concentration, and volume times concentration equals moles. So I can take those two pieces of information and put them together. I've got 0.1 moles of NaOH per liter of solution times the volume of it. I'm going to go ahead and take from milliliters to liters. I've got that volume of that NaOH solution. Okay, that's going to allow liters to cancel out. That gives me moles of NaOH. From the stoichiometry in the reaction, 3 moles of NaOH react with 1 mole of H3PO4, phosphoric acid. That cancels out moles of NaOH. So if I want concentration, it needs to be in the form of moles per liter. I've got the number of moles. All I need to do now is divide by the number of liters. It was 30 milliliters, which is 0.03 liters of solution. I've got moles over liters. So if I did the math and multiplied out, that would tell me whatever my concentration is. All right, so if we can get something redox here. All right, gas evolution. Okay, Sime oxidation states. You got your priority table. What about this first one?
0.
0, elemental state. What about the second one?
3.
Plus 3, because it's a monatomic ion. That's simple. All right, so I've got all the rules written below us to remember. All right, In C, what did I do then? What takes priority? Chlorine. Carbon, or the copper, is a transition element in the middle of the periodic table. So its oxidation state is going to be determined by what it's paired with. So the chlorine has a value of what then? Okay, so the chlorine's a -1. So there's 2 of those. What does that mean the copper has to be? It's got to be +2. All right. Methane. Hydrogen's +1. It's a neutral compound, so what does that mean the carbon has to be? It's got to be a -4. Right. Last one. Dichromate.
Oxygen.
If the oxygen's 2-, that means it's a polyatomic ion. It's got to come out to -2. So I've got 7 of them. 7 times a -2 equals, okay, plus 2 times something comes out to a -2. So what is the question mark on it? It's got to be +6. And this is the toxic form of chromium. Chromium +6 is the very bad form for you. Okay. All right. I'll look at the notes. There's a couple more slides. We may do those tomorrow to start class. Last couple of slides. Start preparing for this test. Yep. Okay, but the oxygen, it wants to know each element on the oxygen is -2. Each one of them.
Yeah.
Yeah. I think it's, you want your Wi-Fi out.
Okay, well, I'm sure that's it.